Hello, I'm Fauzan and I'm here to present to you my final year project titled Privacy Preserving Keyword Search on Encrypted Database. So from the title you can guess that my project is about hiding your search information data from the search engine provider. Before we get into our main points, let's talk about some background information. So, according to Forrester research done in 2016, 93% of web traffic come from search engines. And this is a very big value, and this poses a very big privacy problem because it means that a lot of users' data are gathered by the search engine providers like Google, Bing, and many others, and they are used for their own purpose, which can be used for personalized recommendation, suggestion, or ads. While there are some current solutions available in the market like DuckDuckGo, Quan, or SearX, these current solutions still have problem, which is that the privacy is based on trust instead of by design, because we cannot know what they actually do with our data, but we just trust them that they don't collect our data for their own purpose. So let's talk about some previous studies done to hide our information from the search engine. So this can be done with some types of encryption. There are several types of encryption available, such as property preserving encryption, identity based encryption, and searchable symmetric encryption. All these type of encryption have the common goals, which is to minimize the leak of information to the server and optimizing the performance of the search. And each have their pros and cons. My project particularly focused on searchable symmetric encryption. So if there is already encryption SIM used to hide our data, what are we actually doing? So what we're doing is to create the client server model for this searchable encryption SIM, because this kind of model is important to demonstrate the feasibility of searchable encryption in real application and show that it is possible to be implemented in big scale search providers such as Google. So what is our objective? Our objective is to create an implementation of encrypted search as a web application. The web application must be able to be opened by modern browsers such as Google Chrome, Mozilla Firefox, without any additional installation. This is very important because we don't want to install any other programs when we open a search engine. And the implementation of SSE encryption SIMs will be based on Gaussian code library. Next, let's talk about the algorithm of searchable symmetric encryption. So the process is divided into two phases. The first is setup phase and the second is search phase. In setup phase, the encrypted database is created and this key is generated. So firstly, a key is chosen by using pseudo-random function, which is a deterministic function, and create a list L. Then suppose that we have this inverted index which maps each words available to the files that contain that word. For each word for example, word 1 here, we generate two keys, k1 and k2, from some kind of hash function f using the word itself and the key k, which is generated earlier, and we initialize a counter c from 0. For each ID, which in this case is file 1 and file 2, we create L and D. The L will become the key in the inverted index and the D will become the value. L is F of C and K1, and D is encryption of ID and K2. So for each ID, the C is incremented. So for word 1, for file 1, the C is 0, and for file 2, the C is 1. Then each of this pair of L and D is added to the encrypted database. The same will be done for all the words available. Next, in the search phase, when the client wants to search for word W, it again generates the keys K1 and K2 using the same methods before, and send the K1 and K2 to the server. In the server, the f of K1 and C from 0 until it returns nothing, the key in the encrypted database is matched with that value. So if we get fk1 0, we return the ID by decrypting the K2 by decrypting the value with K2. Then we output all the result. Next, by knowing the process of searchable symmetric encryption, we can create the flow of the proposed solution. As shown in this image, we have client and server. First, the client needs to generate a key, create the index by parsing the files, and encrypting the index by using the previous methods and encrypting each file. Then the encrypted index and files are sent to the server and stored in the server. When the client wants to perform a search token is generated and sent to the server, and a query is done using the previous method, and the result is returned. Then the return result is only the identifier of the file. When the client wants to get the whole file content, the client choose one of the file and the identifier is sent to the server, and the server will search from the stored encrypted file and return the encrypted file. Then the client needs to decrypt the file in the client to get the original file. Then we have the architecture of our proposed solution. There is a user here and three main components, which are store client, web server, and the search client browser. The process starts by the user giving the input to the store client The input can be the username and password of the user, which will be sent to the web server for authorization. And the user also input the files, which will go to the indexer, and the inverted index is generated, and the index is encrypted and encoded. Then it's sent using HTTP to the web server. When the web server receives the index and files, it needs to do some parsing here in the upload controller, and the result is stored in this encrypted file store. Now when the user wants to search for their files, they open the search client in web browser. They'll log in the login page, which sends the credential to the web server and authorize the user. Then the same key which is also used in the store client is generated in the browser. And in the search page, when you want to search for a word, the tokens are generated. These tokens are the K1, K2 from before. And these tokens are sent to the search controller here, which will query the database according to the user. The result is then sent back to the client. When the user wants to get a specific file, they choose a file and request this encrypted file store, which will returns the encrypted file. Then the search client needs to decrypt the file into the original file using this decryptor here. Next, I want to talk a bit about the tools and frameworks used in this project. The first is Eclipse, which is an IDE usually used for Java. Because our project is written in Java, there is also Maven, which is an automation tool to build projects in Java. And there's also Crypto.js, which is used to implement some crypto algorithms in JavaScript. And lastly, there is Spark framework, which is a framework to easily create a web application in Java. Now I will show you a demonstration of my application. So I have my codes open here in Eclipse IDE. I've already run the application, and I've already run the storing for two users called test and test2. For the first user, I uploaded some txt file here. Let's see one example like this. And for the second user, I uploaded PDF file, as you can see here. So for both users, all these files are sent to the server and stored in encrypted format. For example, like this. Notice that the format is in base64 for both txt and PDF. So let's see the application. First, let's log into the test. Try to search for something. For example, bowl. You can see that it returns 3 files, and if you click one of the file, you can download it after the file is decrypted in the browser. You can see that the same kind of file is downloaded. Now let's start. Let's try the test 2. Let's search for the same keyword. Here we get different result from when we search in the test user before. Let's try to download this. Now you can see that we get the correct PDF result. If we search for a random string, it will say that no result is found. So that is all for my demonstration. And lastly, in conclusion, this project showed the possibility of client-server model of SSE in the form of web application with minimal installation of requirement or dependency in the client side. While it works, there are still some limitation to the SSE SIM. For example, the time to create the index. And this creates overhead in the uploading speed. So I think that further research is needed to find an effective compression method for the index. That's all for my presentation. Lastly, there is a reference list here. Thank you for all your attention. See you next time.